Hello students, today we will learn about the development of the atomic theory. The objectives for this lesson: first, describe some of the experiments that led to the current atomic theory. Second, compare the different models of the atom. Third, explain how the atomic theory has changed as scientists have discovered new information about the atom. So it is like learning the history of how the atom is discovered. So we will know some of the scientists that contributed to this atomic theory. So the beginning of the atomic theory, around 440 BCE, a Greek philosopher named Democritus thought that you would eventually end up with a particle that could not be cut. He called this particle an atom. It's like, do you still remember what an atom is? Well, an atom is the smallest unit of matter, or the smallest particle of matter. And Democritus said that if you cut matter or something, an object, you will come up with a particle that you can no longer divide or cut. So that is his discovery or his theory. And then there's another Greek philosopher named Aristotle. He disagreed with Democritus' ideas. He believed that you would never end up with a particle that could not be cut. And since Democritus has a strong influence on people's ideas, so for a long time, people thought that that Aristotle is right. And Democritus, as they experimented and studied everything, so they learned that Democritus was right, because matter is made of particles which we call atoms. An atom is the smallest particle into which an element can be divided and still be the same substance. What does this mean? For example, you have 1 gram of pure gold. It's only gold. Gold is an element, but you got 1 gram, or you got 1 milligram, and 1 milligram of gold has, let's say, 1 million atoms of gold. So you can divide into 1 million atoms, but still it is the smallest particle, 1 atom. Even if you separate all the different atoms, like if you have 1 million atoms, you take 1 atom of gold, that is the smallest particle. And he said that it can no longer be divided, or you cannot cut that atom anymore. Now, another scientist named Dalton, or John Dalton, published his atomic theory in 1803. So his theory stated that all substances are made of atoms. Atoms are small particles that cannot be created, divided, or destroyed. Atoms of the same element are exactly alike, and atoms of different elements are different. Like a pure 1 milligram of pure gold. Even if you divide that 1 milligram, you will still come up with 1 atom of gold that is the same to the other atoms of gold in that 1 milligram. Okay, and atoms join with other atoms to make new substances. When atoms join, what do we produce? We produce like a compound, right? So if you combine 2 atoms of hydrogen and 1 atom of oxygen, you form a new substance, which is water. But then the atomic theory was then changed to describe the atom more correctly. because during that time they keep on experimenting and gathering more information, and new information was found that did not fit some of Dalton's ideas. So the atomic theory was then changed to describe the atom more correctly. So the atomic theory was changed. So there is another scientist named Thomson, and he discovered the electrons, which is one particle of an atom. Thomson experimented with a cathode ray tube, like the one shown in the next slide, which I will show you. He discovered negatively charged particles that are now known as electrons. This is a picture of a cathode ray. So the cathode ray, almost all gas was removed from this glass. So it's like it formed a vacuum here. And then an invisible beam was produced when the tube was connected to the source of electrical energy. And if you can look at this one, there are metal plates here that can be charged with positive and negative. Okay? So when the plates were charged, the beam produced a glowing spot here. Okay? Okay? And after being pulled toward the positively charged plate here. Okay. If this one is not charged, for example, this positive and this one, the negative, it's not charged, then if they put the glowing beam will go straight here. Okay? But then when the plates were charged, like when they opened the negative charge here, or they opened the positive charge here, the beam made a glowing spot here. If you put the positive charge here, so the beam will just like bend and go to this spot, meaning that the beam has a negative charge and it is attracted to the positive charge. If you change this one, you put this one as negative and you put this as positive, you charge this as positive and this one is negative, so the beam will go to this part, because the negative charge will be attracted to the positive charge. Okay, so that's how Thomson discovered that this beam has a negative charge, which later on he called electron. So after learning that atoms contain electrons, Thomson proposed a new model of the atom. Thomson thought that electrons were mixed throughout an atom like plums in a pudding. This is the picture. This is like, because during his time, this is the famous dessert, plum pudding. Okay, but now maybe in our time we can have the chocolate chip muffin. Like the chocolate chip are all spread throughout the muffin. So this one, and that's what Thomson thought, that the electrons or the negatively charged particles are spread all throughout the atom. So that is his theory. Now, another scientist, Rutherford, he experimented on the gold foil experiment. I'm not sure if you read or watched the video that I assigned to you in Khan Academy regarding the gold foil experiment. And Rutherford discovered that there is a positively charged particle in an atom. This is how he did the experiment. Okay, this is the gold foil experiment. Here in this the middle here, that's the gold foil. Okay, gold foil, just like the aluminum foil, but this one, instead of aluminum, it's made of gold. Wow, I want to wrap my sandwich with a gold foil. Okay, so an element such as radium produces the particle. So the particle is a positive charge particle. So the lead stopped all the positive particles. This is the lead part, like a metal lead. Stopped all the positive particles except for a small stream aimed at the gold foil. Okay, so when the particle or this beam goes through the foil, in the beginning he was thinking that all this one will pass through in a straight line, but then he discovered that some of it deflected, but most of the particles passed through a straight line through the gold foil, through the gold foil. But then some particles were slightly deflected, and some particles even bounced straight back. So when it passed here, most of it went straight, but some deflected, some even bounced back. Okay, so what was his conclusion? He proposed that in the center of the atom, for example, this is the atom, is a tiny positively charged part, and he called it the nucleus. So he discovered the nucleus, the proton inside. And he said that this one is the dense part of the atom. Remember, we learned about the different subatomic particle, and the nucleus is the dense part where you can find the proton. That's why this is a positively charged. So when the ray goes through here, some will go straight like that. But then since it is positively charged, when it hits the nucleus, it will repel because the nucleus is positive. So either when it passes here, it will deflect like that, or will bounce like that, or will go like this. So because this is positive and the ray or the beam is positive, so it will not be attracted. It will repel. So Rutherford discovered that the atom has a nucleus in the middle, and it is positively charged. So another scientist named Bohr, or Niels Bohr, proposed that the electrons, remember, Rutherford also said that the negatively charged particle or the electrons are spread throughout the atom. But Niels Bohr proposed that the electrons move around a nucleus in certain path or energy levels. I've talked about energy levels last year when we talked about remember the electrons in the different energy level. The first energy level can contain only like 2 electrons, then the next level 8. Remember that when we were talking about the ionic bond? I don't know if you still remember. Anyway, so that's Niels Bohr. That is his proposal. And the modern atomic theory, according to the current theory, there are regions inside the atom where electrons are likely to be found, and these electrons are called electron cloud. Okay? So if you watch the video and if you read the other articles that I signed to you in Khan Academy, you will learn more about this lesson. Okay, so if you have other questions, you can message me or send me an email. Okay, I already attached or uploaded the book or the section, the section of the atomic theory, and you can just open that so you can read more about it. And I'll send you the DRA after this. Okay, bye.